Good day, my distinguished listeners. Today we'll be having another edition of our online chemistry classes. We'll be looking at gas laws, but I want to draw our attention majorly to Gay-Lussac's law. We're looking at Gay-Lussac's law. Now remember, we have so many laws. We have the Charles law that talks about volume and temperature. We have the Bohr's law that compares volume and pressure. We have Dalton's law that talked about partial pressure, and then here we are with Gay-Lussac's law. Now, what does this law state? It states that when gases react, they do so in volume, which are in constant ratio with one another, and the product, if gaseous, please remember, if gaseous, provided that all other external constraints are kept constant. Okay, now having done this, we have a question before us. It said 30 centimeter cube of carbon 2 oxide, that's CO, are sparked with 30 centimeter cube of oxygen. And the question is, if all the volumes are measured at STP, that's standard temperature and pressure, the question is calculate, number one, the volume of the product if gaseous, number two, the total residual gas. Okay, now the first thing we do here is to write the equation of the reaction. We are told that CO was sparked with oxygen. Now, if that reaction happens, this is what we call combustion reaction. We produce what? CO2. Now, this is carbon 4 oxide. Now, if you look at that, it's not balanced. I have 3 atoms of oxygen on the left-hand side and 2 on the right-hand side. So, if I try to balance things here, by the time I put 2 here, I'll have 2 here, 2 here. Having 2 here, then I'll put 2 here to balance things up. So, I have 2 atoms of carbon, 2 atoms of carbon on this side, 2 oxygen, making it 4 on this side, then 2 times 2, making it 4 on this other side. So I have a balanced chemical equation. Now if I put the ratio, this is 2, ratio 1, then ratio 2. Now let's consider the volume given to us. Volume given for CO, carbon 2 oxide, we are given 30 cm cube. Now for oxygen, we are also given 30 cm cube, but for products, we are not given anything. Now, let's place something here. If I decide to use 30 centimeter cube of oxygen, it means I need 2 portions of 30 of CO for the reaction to complete, meaning I will need 60 volumes or 60 centimeter cube of CO, which I don't have. So what does this mean? It means that CO becomes my limiting species. If I use 30 cm cube of carbon monoxide, it means I will need half of 30, which is 15 centimeter cube of oxygen. I was given 30, meaning I can go with 30 here, 30 centimeter cube, as against 15 centimeter cube. Now, if you look at the mole ratio, if here is 30, that means the product will also be 30 centimeter cube. Now, let's look at the residue. What is remaining? Now on the residue for here, I was given 30, I used up 30, so this is 0. Now for oxygen, I was given 30, I used up 15, so I have 15 centimeter cube here. And then for the product, I was not given anything, but I have 30 cm cube of the product left in the system. Now the first question is the volume of the product if gaseous. Now the product is CO2, so volume of product from what I have here is what? 30 centimeter cube, because the CO2 is the product. Now that's question 1. The question 2 is the total residual gas. Now when we say total residual gas, we are looking at the amount of gas remaining in the container. So I have a residue of 15 from oxygen plus the product, because product is also present in the container, and I'll arrive at 45 centimeter cube. Okay, now that is the volume of the product, and this is what? The volume of the residual gas. Thank you very much. God bless you. Don't forget to like, follow, and then your comments in the comment sections. I will see you in the next class. God bless you. Take care.